So normally, I actually managed to get away with this. Finish? All right, and we're done. Now, normally, I actually managed to get away with this at the Rocky Mountain event. Bruce said he wanted to have something with gogoNET on here, so I ended up putting in an intro slide. This is a single slide presentation. Is everyone happy about that? End of the day, single slide presentation. So we're going to be talking about advanced IPv6 deployments for Windows, specifically around Microsoft Enterprise deployments. That's really what my goal about talking around v6 is. So everything that you heard today about networking and all that cool stuff, don't care about any of it. We're only going to be talking about Windows and what happens in the Windows world, all right? Because no other operating system matters, no matter what Owen wants to think. And so we're gonna do that. I have some assumptions. I assume you've actually done some IPv6 design work and deployment. So hopefully that's a safe bet for everyone in this room on Windows platforms. You've done some IPv4 DHCP and DNS. You've done some routing and some subnetting because it's going to be useful. You've actually used the IPDs. So if you don't know what these are, Microsoft has IPDs, which are the Infrastructure Planning Design Guides. If you have no idea what the heck they are, you're not a real Windows person. There you go. So first one out of the gate, so Owen's taken care of. And then you need to have some knowledge about IPv6. I did say this was advanced, right? So the first section that we're going to talk about is actually section A. See, I get away with a single slide, but it actually has animation. Does that count? I don't know. We're going to talk about dual stacking at the edge. So I think really the preference is, and there's no doubt in the industry, that realistically you need to get some sort of native IPv6 at your internet edge. Why would I say that? The biggest mistake I've seen Windows shops make is that they actually turn up IPv6 at their access layer and have no route out to global v6 and break their entire network very quickly for internet access. So I think it's one of the things that you really want to address early on. Go ahead and get native turned up at your internet edge. It allows you to be able to build labs and other things very, very quickly. You want to make sure that you actually get the same SLA for v6 and v4. So for those of you that are provisioning circuits and aren't using a tunnel service from Hurricane Electric or anything else of that nature, make sure you get the same SLA. So that way, the day that you actually decide to turn on v6 and everyone flips over to make access to Google and Facebook and everything else happen over v6, the last question that you want to be addressing from your CX level staff is, I don't have the same SLA. I have no idea why that went down. Let me go try and figure out why the heck I have worse support on my v6 circuit than I have on v4. Well, everything's going to happen on v6 once you start moving and migrating services there. You really want to have the same SLA. It's pretty important. Something that a lot of folks who are dealing with circuit provisioning don't think they have to deal with it, don't think they have to multi-home the same way. You really do. I would really recommend for those shops that are doing Windows, no 6-4. So no 6-4 should be a plan in your operational model going forward on the Windows platform if you're running an enterprise. There are use cases, but I would say typically 6-4, no. So specifically, product technologies in Microsoft, let's talk about direct access. Direct access is probably the most interesting technology that has v6 utilized within its stack, and I think it's something that deserves a lot of attention. IPv6 is required for direct access. And I'm going to repeat that. v6 is actually required for direct access. How it is utilized in direct access is really specifically for clients, the clients themselves talking to the direct access server. The reality is that in Server 2012, Microsoft did something pretty slick. They decided to integrate NAT64 and DNS64 directly into the server operating system. So the advantage you get is that you no longer have to take the interior core portion of your network and v6 enable it. So your client machine used to be able to, would have v6 on it and need to be able to use this VPN service from direct access to be able to get interior to your network. And the only way that it could actually talk to your SharePoint server or your Exchange server or your Active Directory server to authenticate was via v6, which means you needed to dual stack your internal core portion of your network. Microsoft has removed that barrier. In Server 2008 R2, you used to have to pick up Unified Access Gateway in order to be able to solve this particular problem. That gave you the NAT64, DNS64 combination to be able to deploy that. With this, with Server 2012, you no longer have to do that. You get this as an advantage. If you're still on Server 2008 R2, really suggest that you deploy Forefront UAG, solves that particular issue for you. simplifies it. You don't have to do as much v6 internal deployment. Makes life a little easier. The early recommendation guides from Microsoft talked about doing direct access with ISATAP. I'm probably one of the principal reasons that that recommendation isn't in there anymore. And one of the reasons why is that it's very good to be able to lab up with ISATAP in their configurations in lab proof of concepts. But the reality is for enterprise deployments for ISATAP, Microsoft was not providing any agent that actually told you whether the end client was actively engaged in using ISATAP at all. So there's some challenges with going around for help desk support about, is my device appropriately accessing things via ISATAP for my direct access components? And typically, because they weren't providing that and it wasn't something that they could deploy in System Center, they agreed with me on that recommendation and said it's better to recommend doing a native or a dual stack deployment of v6 and telling people to do that inside their enterprise environment and using that as a recommendation, plus it pushes people to get on the bandwagon and get v6 deployed. One of the other odd recommendations that Microsoft has in their IPD is that they actually tell you the direct access service to be the default gateway for your IPv6 traffic. I actually don't agree with that recommendation. My recommendation is that you should be pointing the actual prefix that you're utilizing for your direct access clients to the direct access server. The direct access server should be doing what everyone else is doing, sending the default traffic to the appropriate default gateway upstream through your internet peer. So you should be doing that internally on your network anyway. Your default route for your v6 traffic should be going to your appropriate routers and firewalls. They should not be pointing at the DA server at all. Okay? Makes your life easier. It solves some black hole problems that are a little ugly. All right, I think I covered everything there. Next one up, firewalls. You're going to need to dual stack your firewalls if you're going to be doing dual stack deployment. Unfortunately for you today, if you're using Microsoft Forefront TMG product line, there's no planned support for IPv6 and TMG. This means that you're going to be needing to introduce an alternate vendor, whether that's Palo Alto, Cisco, Juniper, or anyone else that's going to handle v6 traffic for you. This means you're going to have a different path for v6 egress traffic than you're going to have for v4 if you're using TMG for that firewall purpose. If you're using TMG for proxy services, application proxy services, you're going to need to find an alternate method to do that as opposed to utilizing TMG. So you just be aware that you're going to have to look at an alternate product. So commonly, application delivery controllers are deployed often with SharePoint Exchange for OWA for client access. And this is one of the areas that Microsoft has deferred to those manufacturers to say that we are going to partner with application delivery controllers to provide those service offerings for Microsoft. Not going to be trying to make a high available service offering. So those of you that suffer through network load balancing with Microsoft platforms with clustering and like are ready to pull your hair out and don't want to support it anymore, you can clap your hands. They have seceded and said, okay, we're going to stick with application delivery controllers to provide those high available service offerings. That being said, if you are not making your SharePoint site dual stack, you're going to have to stick some sort of appliance in front of it. At this point, it's very convenient to do something with SLB 6.4 or another transition proxy service that you want to make available at that point. That is how you're going to get those particular service offerings out to your end clients. If you have an older deployment of direct access that does not have NAT 6.4, DNS 6.4, this is actually how you would enable your end clients to be able to access resources for either OWA or any other service would be through a SLB 6.4 device that is sitting in front of that v4 service. So in your DMZ, this is what you would do for OWA, for instance, with Exchange, and this is what you would do with your SharePoint services on your internal network if your SharePoint was internal. One caveat on that one is that you still may run into bottleneck and performance-related issues, and so that's one thing to consider is how large a traffic volume you're taking in. So you still want to be able to measure and have some good data on that before you actually deploy those solutions. So the next section we want to talk about, probably the biggest product platform that gets deployed on the Microsoft side outside of Active Directory for enterprises is Microsoft Exchange. Microsoft Exchange is sort of a unique Microsoft product family. It has multiple roles, and one of the multiple roles that is explicitly deployed in the DMZ, in this case we'll call E the DMZ here. That Exchange role is interesting because they actually tell you for what's called the edge transport role. The edge transport role is unique because the standard deployment is either leave it as a standalone server, so you don't join it to your domain, so it's a little unique that way, or you're setting up a special domain simply for that edge transport role. I have not seen a single corporate deployment yet of setting up a separate domain for that. Almost everyone I see deploys it as a standalone. There's different behavior for the Windows operating system, for server, in a Active Directory joined role versus a non-AD joined role. And one of the interesting things you get, especially for enterprises that are deploying public v4 address space in their DMZ, which is not that uncommon, is you're going to see behavior like 6-4 being turned on automatically. So your device is going to do 6-4, and Exchange for SMTP role is going to basically do an outbound query for DNS and say, I need an MX record. If there's a quad A that responds back, your box will fire up 6-4 and respond with v6 traffic on the outbound basis to try and deliver that email. This becomes an interesting issue about trying to debug it, and Chris knows about this directly because you ran into this. So this is a real world problem. This is not something that's fake and imaginary. This happens to enterprise deployments when they're trying to solve this. And something that you need to be aware of. You need to have the right policies enforcements in play on your edge boxes for v4 in the world today, depending on what happens for them in terms of v6. So even if you are running a purely v4 network today, but you happen to have a public IPv4 address on your Exchange edge transport role, if you did not turn off the flag to enable 6-4, your box will try and deliver email, SMTP email, over v6, over 6-4. So everyone who is in the room who thinks I'm not running any v6 at all on my network, I have a v4 only network, a single DNS quad A return record for an MX changes your life that quickly. So it's one of the things that you really need to keep an eye out on. The other recommendation really is, realistically, turn off 6-4, turn off ISOTAP, and turn off Teredo for those edge transport roles. And actually, as a practical recommendation, everything in your DMZ. Those roles shouldn't be there unless you explicitly design that you need tunneling for those service offerings that sit in the DMZ. No reason to do them. One of the other things, really should have a static address. You want it sourcing its traffic from that address so that you can appropriately log it. That means that you need to be turning off Slack appropriately to make sure that you're not provisioning additional addresses. Things of that nature. You probably want to be doing a static implementation to make sure that it goes egress with the correct address so that your firewall policy rules all work the way you think they should. Okay? Next one, let's talk about Exchange on the internal side now, not the DMZ, but the internal side is going to be an Active Directory joined device. I would say basically the same rules apply. You really don't want to have any tunneling services turned on. You're probably going to be pushing an Active Directory policy enforcement that's going to control whether you can tunnel, whether you can do 6-4, Teredo, or ISOTAP natively. So that is something that's going to it's going to inherit automatically as Active Directory is pushing those down as policy enforcements. For the CAS and the hub role, really recommend you use some sort of application delivery controller to make them high available. So you're going to need to look at a product vendor in order to be able to support and do that for you. And you really utilize group policy to do the enforcement across the board for your server platform line, Exchange included. All right, so for this section, let's talk about file and print real quickly. Microsoft products are principally used for Exchange, file and print, and SharePoint. I would say those are the top three that fit out there. For file services, you really want to dual stack your common file servers. And the reason why is because you now address the entire family of, if you have direct access, you have an older deployment direct access, and it's v6 only on the client side, you get the advantage of you don't have to put any transition services, no proxies in the way for that direct access client to access your file server. So it's one of the areas that you actually want to do an early implementation, test your file servers, test your Active Directory server, that's actually hosting Active Directory, to make sure that they're actually dual stacked. One of the advantages with dual stacking your print server is that you can continue to take print pooling. So the spooling process for your print services that you're making available in Active Directory may come ingress via v6, but your printer may only be talking v4 still. It will pull that process. It will still be able to print to a v4 printer. So the advantage you get there is that your clients could be doing v6, your printers could be doing v4. Because your file and print server is dual stacked, you're able to actually transition. It makes it an easier transition, longer lifetime for your v4 printers. You're not having to replace them as quickly. A little easier on the transition side. So that's a big plus. Branch cache. Branch cache is one of the advantages on the file services. So if you're doing a server 2008 R2 or a server 2012 and you're implementing branch cache takes advantage of IPv6. It does the optimization for IPv6, and it can actually help with the transitions between both v6 and v4 because it utilizes Active Directory integrated DNS. It can get the difference between a quad A, dual stack, and a single A record v4 configuration and know how to manage that. So you actually can get some strategic advantages of being able to utilize branch cache in dual stack and single stack environments. So those are pluses. It really doesn't care. It's doing it by name for the host and by a file hash. And so it doesn't care whether it's dual stack or single stack in those configurations. As long as you have some device in the path that's able to do both, it's a better solution for that. So H, we'll talk about Active Directory and group policy. One of the things that's most commonly missed for teams that I'm working with in Active Directory is that they forget to map. Today you map your v4 resources in sites and services, sites and subnets. So you probably go through and you have a global map configuration of how your network looks, and you map that out to your Active Directory configuration to make sure that your directory replication is going to work the way you want. It's in a predictable replication configuration that matches your v4 to a logical entity around your Active Directory configuration. You need to do the exact same thing with v6. So when you're finished with your v6 design, you actually need to go into sites and services, sites and subnets, and believe it or not, it takes v6 entries. Microsoft actually did this correctly. You need to map your v6 sites and services subnets components so that your Active Directory replication is going to work properly. It's going to work in a predictable fashion. It's going to work in the way that you think your v4 replication is going to work. So all the hard work that you did in v4 is for naught the moment you turn up v6 and did not do this process. And why? Because your machines are going to prefer v6 over v4, and you have broken every single bit of high availability and WAN link controls and distributions for Active Directory that you did on v4 planning the moment you turn this on and didn't do it in v6. So an important caveat. Domain controllers are handling your authentication for direct access, for SharePoint services, for Exchange, for Link, for all the other product clients. You need to make sure that your Active Directory servers are properly doing v6, properly supported quad A records are getting published in DNS, and that in these environments that you're seeing things within your logging system that look predictable in the same fashion that they do in v4. So directory replication logs, you should be seeing both v6 and v4, depending on which they are. They hopefully convert straight to v6, and you don't see any more v4. That will happen on your network. So one of the things you shouldn't be alarmed about is if you're using Nagios, you're using some other alerting and log system, and you have a layer 3 interface in there, and the layer 3 interface is reporting, for instance, off your router. You may see, and you transition over for v6 for your Windows environment, you may see a massive drop in the amount of v4 traffic on that logical interface. And if you didn't bother to add the logical v6 interface to your monitoring, you will see no equivalent uptick in traffic being picked up there. You will wonder where 80% of your traffic went. And then you panic and you say, I turned on v6 in my Windows environment, everything went wrong on my network, I must be losing traffic. You just aren't recording it properly anymore. So you need to make sure that you get those done before you actually turn it on. One of the things that's an additional component for group policy, there are specific IPv6 group policy objects. You need to document and find out what they are and make some of these available. They allow you to control the IPv6 behavior. Those are the policy enforcements that you have to push out in Active Directory through group policy. One of the most common deployments out there is IIS and SharePoint for Microsoft Product Platform. IIS has full IPv6 support built in. And therefore, so does SharePoint. SharePoint leverages IIS, so there's no real extra work that you have to go through on SharePoint in order to leverage what IIS already has. SQL Server has some additional component challenges that you may have to deal with if people did some odd things with embedding v4 address information in their SQL query components. So you will need to clean that up. You'll need to find out what's going on. So one of the things that you need to be careful about is that if it's using name resolution for portions of connecting to the server, but you're doing v4 specific socket connects out of SQL, you're going to need to clean that up before you actually turn on runtime environments. You're going to need to test that in your lab. So there's some funny, odd combinations of SQL that you can get into with v6 and v4 where the SQL process ends up hanging and not quite working correctly. If you do everything right with just namespaces, you should be fine, but there's some older implementations I've seen where people do odd things with v4 embedded. Web parts, this is the interesting thing. For those that test with the application team, and you have web parts in SharePoint, you need to find out if the third-party web part that you're referring to supports v6. And what do I mean by that? If you're using a third-party web component and you're presenting to your outside world v6 accessible site, so you've turned up v6, you have IIS with SharePoint running as your production site in your DMZ and providing external resources to get to that, and you have a web part that's a component plugin. If that web part is pulling from the outside world a v4 resource or doing a redirect for a v4 resource and the client is v6 only, it will not see that web part. And hopefully that makes sense. It has no capability to reach across to get any v4, so you may have to put a transition solution in play in order to present that web part to the client that's actually requesting it. So it's not as seamless as you think. The app developers probably aren't going to see this, and this is why you need a v6 specific design and test area that actually is a v6 only client trying to access that SharePoint or IIS system to see that. CAS roles. IIS is utilized by Exchange in order to present the OWA CAS role set. You're going to use application delivery controllers to actually figure out what's going on there. Certificates. Certificates pretty much don't care about whether you're using v4 and v6 unless you actually were, interestingly enough, decided to embed any sort of v4 information in your certificate. You might run into some issues there. You want to double check and make sure that that's not going to be a problem for you. Hopefully your application delivery controller can handle that for you. So J, let's talk about the actual client OS, Windows 7, Windows 8, because no one's running any other OS. So no one would be running XP, right? God forbid you're not running me or Bob or no. So Vista, Windows 7, Windows 8, they're all IPv6 capable OSs, have good IPv6 support. I would say Microsoft has done a wonderful job of being early on the v6 support adoption within their client OS. I would really recommend that you actually do not use IPv6 on XP. Let me repeat that. I really suggest you do not use IPv6 on Windows XP. It is not, it has specific components that are not current on RFC, will not be fixed, and do not plan to be fixed by Microsoft in any sort of patching configuration. So I really recommend that at this point you get off of XP, do not use it for any testing, do not use it as your platform going forward. You need to be using Windows 7 and moving forward on that. You guys are laughing because I know you have one. That's all right. The Windows clients have transition technologies turned on automatically, principally thanks to Tony. So we have 6-to-4 Isotap Teredo and on the newer side, IP HTTPS. The reality is for enterprise deployments, for better control of understanding your environment, I typically recommend that unless you have built a specific tunneling transition technology solution, in other words, you decided to build a service block architecture for Isotap, make it high available, understand what application suites you're going to make available over Isotap, that you turn them off. So you actually do a group policy enforcement that turns off all of the tunneling transition technologies. That way, you will still support v6 natively. So when your network team decides to get around to turning on v6 on a native access side for support and deployment, your OS will work and do the right thing. It just won't be doing tunneling. If you have a specific need for tunneling because you need to get around legacy equipment, you have very specific need requirements, you should do that. You should be a design solution. You should make it high available. You should understand what you're getting into, have appropriate security measures, application inspection, everything else. v6 is for all of the operating systems for Vista, Win 7, Win 8. It's preferred by default. So you are going to have v6 preferred by default, and it's used by default. So if it's there, it's going to be used. It's going to be first out of the gate. Happy Eyeballs, RFC 6555. Andrew was here yesterday. Dan Wing was here yesterday. So two that actually wrote Happy Eyeballs. One of the things that was interesting about Microsoft's decision in Windows 8, and now with the backport for Windows 7 that just got, Scott was good enough to turn me on to that they just patched and released an update for. One of the interesting things that Microsoft had as an internal discussion was really, do we want to fully support happy eyeballs in our operating system? What impact does that have on our OS? Who is the principal people that use our operating system, and what impact will this have? So my opinion, this is just my opinion, I'm not a Microsoft employee, but one of the discussions that went on internally, and a little privy to it, was the fact that they said, how do we help application developers really understand and debug what's going on with their application suite? We have developers who are using Visual Studio to build custom applications for enterprises. The last thing in the world we want is unpredictable behavior between an application making a call with Visual Studio and sending the request out, and one time getting v4, and the next time getting v6, and the next time getting v4, depending on what the underlying OS was seeing with happy eyeballs. Am I getting better behavior with v6 right now? Maybe I'm getting some weird asymmetrical tunneling. I'm getting longer delay. First request goes out with v4. That tunneling delay improves. Next request goes out with v6. How are people going to debug their application environment in this? It's not a supportable environment for them to be able to figure this out. To simplify that process, they decided to leverage what they already have in place today. So the network connection status indicator, which actually is a little portion that comes up and says, yes, you're connected to the internet. They decided to leverage that process for v6 to determine whether a legitimate global v6 address that's on your box is actually able to reach out to the global IPv6 internet. There's some very good blog articles up on TechNet that talk about some of the timeouts and thresholds that they're utilizing. But the reality is they chose to do that instead of a full implementation of RFC 6555. I think this was to the chagrin of Dan and Andrew to a certain degree, but the reality is I think it was a reasonable decision given the position that Microsoft is in. For the amount of application support and development and custom application support and development that happens in enterprises, it was a reasonable position to take. We can argue that offline maybe a little later. So the next portion is the WAN. The great news here is that we're dealing with Windows. Windows doesn't work on the WAN, right? Just teasing. But the reality is the network, most of the folks in the room have spoken about challenges on the WAN side. Dual stack, everything's going to be good. If you're doing ISOTAP as a specific deployment, ISOTAP should work just fine over the WAN. There should be no issues. It's just more of an issue of making sure that your clients are configured correctly to support it. There are some interesting things that come up. We'll talk about remote VPN sites. If you folks are doing things like with Cisco with DMVPN, perhaps you're using your branch site router to actually service the function of local internet hop-off, you're going to get slightly different behavior with v6, perhaps, than you're going to get with v4. And so there's some interesting challenges you might go through on that. So let's talk about your remote office. Your remote office, still standard recommendation, dual stack. There is a chance that ISOTAP could cause some breakage in remote site configurations. The reason I bring that up is simply because depending on how your WAN configuration is working and if you're using tunneling for ISOTAP all the way across from the remote branch into your core and you don't have a high available ISOTAP deployment done, you can run into some challenges of your clients not being able to access resources and having them then be isolated. You also may run into some challenges if you're doing VPN backups where the ISOTAP is not going, you're going to be doing tunneling across tunneling again. You might run into some challenges of MTU sizing and things not being as happy as they should be for that. You need to be able to have some sort of agent on the box that is giving you information about whether the v6 is reachable or not. Your help desk team needs to be aware of the appropriate tools to test to be able to find out if they have v6 access, if your application suite is v6 only, and whether that is working at that moment. So let's talk about one of the sort of unique challenges in the branch location. If you're doing today v4 with local internet hop-off, you're natting at your firewall edge and sending your client machines off to reduce the amount of bandwidth that you consume on your WAN, and there are a lot of enterprises that are doing that today. If you happen to do a v6 deployment and you're doing provider-assigned addressing, you have a choice. Do I use provider-assigned addressing in my branch office location and then just do routing as transit and accept that those addresses ingress into my network but still globally set their default out the local internet provider? Or if I do provider assigned, what do I do to break up my numbering schema for addressing to do provider assigned? And then am I planning on doing BGP at all my internet edge locations to be able to make sure that that traffic goes egress properly? So that's a choice for companies, but you do need to think about it. This is where the behavior is different between v4 and v6. It becomes an interesting use case about how is my traffic actually routed at that egress point. ISOTAP, the specific ISOTAP configurations, I really recommend that you read Shannon's book about high available ISOTAP deployments. I'm not opposed to doing ISOTAP in the proper configurations. I'm just opposed to it for proof of concept labs that move into production with no high availability. And that's been the biggest challenge that early Microsoft shops have done. They did a direct access deployment with ISOTAP as a proof of concept in the lab and turned it live, and then had failure points within ISOTAP that they weren't able to work around. So you need to make sure you're doing Anycast properly, making ISOTAP high available, you've got your service block architecture done. And with that, that was a single slide presentation, not bad. Oh, okay, 2 slides, but not bad, right? Windows, it's my personal belief, Microsoft on the Windows platform has done a remarkable job of doing early support for IPv6 and continued development on IPv6. And regardless of what you feel about the company, Owen, the reality is that Tony did a remarkable job of moving that company along the line of saying v6 is very, very important to have in a client OS, and probably the most ubiquitous client OS that's out there. And for those that are starting to look at cloud and Azure services, v6 is becoming a very strong component of what they're doing in cloud and Azure for Elastic. So once again, the story around v6 and cloud, that is going to have, you're going to see some very interesting things coming out of Microsoft in regards to what's happening there. Thank you very much. And I wanted to bring Bruce back up here. You had a couple closing things, right? What? Yes?
Question. In terms of Active Directory on your remote in v6, are there some issues if you're trying to do various configurations of Active Directory on your remote site?
So this is my portion about saying if you're going to dual stack, try and dual stack everywhere for Active Directory. If not, make sure that that sites and services component is handled correctly so the replication is going to work. Your v4 replication is still going to continue to work. So in a mixed mode configuration where maybe portions of your site are v4 only, portions are dual stack, and maybe even portions are v6 only, as long as you set up your replication services in the right order for v6 to match and for the dual stack box to have that same, and then for the v4, as long as that replication order set is done correctly, you should have no issues with replication moving through the network. The biggest problem I've seen is when people don't go into sites, services, sites and subnets and get that laid out correctly. Question?
How many problems come about
So the question was, how many problems come about from the interface selection portion on a policy? So this is really a source address selection issue. This is not unique to Windows. Unfortunately, RFC 3484 and the update, which I can't remember off the top of my head right now. What's the update? Someone in the room must know the update for 3484. Unfortunately, it doesn't actually specify if you have multiple global unicast addresses on there, which one is actually supposed to be utilized. You can go in and set interface preference orders within Windows, so the actual network interface may have preference orders, but the actual logical interface of the IP address that's associated, if you have multiples on an interface, you won't have any control over. It's going to be, I'll have to ask Chris Palmer, but I think there is a tiebreaker for determining if you have a global unicast address. Definitely, there's an order set that's done for that. Right, and that's correct. Yeah, so there's both PowerShell entries, there's NetSH commands, and there's GPOs that you can place on the device that control the order set. So if you want to do a preferred interface for source address selection with a particular prefix, you can do that. So that would be the correct answer if you hard set that. If you were just having multiple prefix advertised, there is a breaking order for that. I think Chris Palmer has a blog entry that actually discusses how that happens. Longest match to the desk, yeah. Yeah, so there's some interesting scenarios that come up with that. So MPTv6, there are some interesting use cases where you can get stuck in a weird rut with MPTv6. Right, yeah, I absolutely agree. I'm not saying it's necessarily right either, but there was no other alternative. There hasn't been anything published that says this is how that's supposed to work on that. You can control wired versus wired port by just doing the network interface preference, similar to how you do for like a docking station today where you would set the preference. V6 would take that same rule set for the interface preference automatically. Scott? 6724 is the update for 3484. 6724, I need to drill that one in my head. I'm so used to saying 3484 now. So 6724, there we go. Jim? I'm sorry, what was that? So the patch that, the question was, is the patch out for the limited sort of NCIS, is that the right order? NCSI, I gotta remember the right acronym. NCSI, I just tweeted about it. Scott has the link back there, so you can go ahead and hit him up on it. I don't know the specific URL, but it is a patch that just came out for an update that will give Windows 7 and Server 2008 R2 the same behavior as Windows 8 and Server 2012. That would be the one caveat. So the question was, if I have a v4 only client and I'm using Direct Access 2012 with NAT64, DNS64, or Server 2008 R2 with with Forefront UAG, can I initiate a session connect request from a v4 client to the v6 client that is sitting resident on the other side? And the answer is no. So your monitoring system, System Center, if you're using System Center, Operations Manager, and you have all your client stations in there for management purposes, that machine will have to be dual stacked in order to appropriately manage those end client node devices. Is that a good answer for you there? All right. Any other questions? Learn anything new? Good.